Hi friends, so in this session we are going to solve one more problem on the flexibility influence coefficient. Those who are watching this video first time, you can refer the other videos where I have explained the concept of flexibility influence coefficient and also solved one numerical on the flexibility influence coefficient. Now we'll solve this problem to determine the flexibility influence coefficient matrix. Now what is this flexibility influence coefficient? It is represented by Aij. Now what is meant by this Ai and what is meant by this J? See, Ai means it is the deflection at point I, and J means due to unit load, means unit force at J. Means if I want to calculate, suppose A12, suppose if I want to calculate the deflection at 1, but that for that condition I am going to apply the load at 2. Means A12 meaning we have to find the deflection at point 1 and but we have to apply the load at point 2. Okay, so this is the meaning. Now here, to determine this influence matrix is nothing but A11, A12, A13, A21, A22, A23, A31, A32, A33. Means we have to determine these all 9 coordinates of this matrix, that is A112, A33. And to determine this, we will have to draw the FBD of the given system. Now, how to draw the FBD? Because to determine this influence matrix, the most important thing is the FBD. So, while drawing the FBD, I am going to consider one case. See here, I will repeat this, what is meant by Aij. Ai means deflection at I due to unit load at J. Means somewhere we will have to apply the unit load. Unit load means the value of load is 1. So, in first case, we will consider that we will apply unit load at mass 1 and at mass 2 we will keep it as 0, and for mass 3 we will keep it as 0, because we will have to apply the load at only one point. So they have given the 3 masses, so I am going to apply the load at point 1. So F1 is equal to 1. Now we have to draw the FBD. Now how to draw this FBD? We have 3 masses, so I will show. This is the first mass. The earlier example that I have solved, that all are having the horizontal masses. Now this is the vertical members, so I am drawing the FBD in that fashion. Means I have taken all the masses in the vertical manner. Now the first mass is 2m, second mass is 2m, and the third mass is m. Now just show the displacement. For first mass displacement is x1, for second mass displacement is x2, and for third mass the displacement is x3. Now we will have to show the forces. So for mass 1 displacement is in downward direction, means the force acting will also be in downward direction. So this will be the force 1, and that we have considered as 1. For mass 2 it is F2, and that will be equal to 0, and for mass 3 this will be F3 will be equal to 0. So I have shown all the displacements and the force which are acting on this system. Now we will show the spring forces. Consider the first spring 2K. This spring will be elongated in downward direction. So normally the force acting in the spring will be opposite to displacement. So its displacement is downward, means the force by this spring will be upward. So I will show the force here. So the force will be 2K, means stiffness, into its displacement x1. So 2K into x1. Now what is this 2K x1? K into x is nothing but the spring force. But but here we'll have to represent this system in the form of stiffness flexibility influence coefficient. So I am going to represent in the form of A. So what will be the value of x1? We are determining the displacement at 1 and we have considered the load at 1. So it will be 1 1. Again I will repeat, we are determining the displacement at 1, so it will be A1, and we have applied the unit load at 1, so again 1. So A11 means displacement at 1 due to unit load at 1. Now what will be the value of x2? Here we will determine the displacement at 2, but we have applied the load at 1, so A21. Now what will be the value of x3? We have to determine the displacement at 3, but we have applied the unit load at 1, so this will be A31. So instead of x1 I will replace by A11 because we are using the influence coefficients. Okay, so just wait, I will remove that x1. Okay, yes, you can write x1, but the value of x1 is A11. Okay, so we have to write this A11. So 2k into displacement x1 means A11. Now to write for the second spring, what we have to consider? Consider x2 is greater than x1. So I will show here. Suppose this is my spring and here we have displacement is x1, here we have displacement is x2, and we will consider x2 is greater than x1. Means ultimately, suppose the displacement of this spring is 20 and at this end is 10. Means if we have the total length 100, so finally after this 20 it will become 120 and after this 10 it will become 110. Means when x2 is greater than x1, ultimate final displacement of this spring will be 110. So final length will be 110, means that spring is elongated. Elongation means this end will move in upward direction, this end will move in downward direction. But the forces acting in the spring are opposite to displacement. This I have shown as displacement. So I will show opposite to displacement forces. So the forces will be like this. Just see, it is opposite to displacement. And what will be the spring force? It will be stiffness K into x2 minus x1. x2 is A21 minus x1 is A11. So K A21 minus A11 will be the stiffness. Now for third case, consider x3 greater than x2. So when I consider x3 greater than x2, again the forces will be like this, same as spring number 2, and the force will be stiffness into displacement x3 minus x2. Now x3 minus x2 is A31 minus A21. So this will be the stiffness. Okay, so we have finished with the FBD. Now it is very much easy to determine. The stiffness coefficients. Now to determine the stiffness coefficients, just see the first column of this matrix. Here we have A11, A21, A31, and just check the value of x1, x2, x3. x1 is A11, x2 is A21, and x3 is A31. Means after solving this FBD, we are going to get the first column of that matrix. Okay, now we'll solve. So to solve this one, I am going to consider the mass one. Okay, so for equilibrium condition. So for equilibrium condition, whatever the things I have written here, these are for reference, so I'll keep aside. Okay, so for equilibrium condition, consider mass 1. Now for mass 1, write down. So in the direction of force, we will consider the positive. So F1, downward direction I am going to consider positive, F1. Then this one is also downward, so it will be positive, K, A21 minus A11. Then this one minus 2K A11 will be equal to 0. Why I have written minus here? Because I have considered downward direction as positive, so upward will be negative. You can consider any direction as positive. By natural convection, normally we consider upward direction as positive. Yes, we can consider, again you are going to get the same answer. Okay, now put the values. What is the value of F1? It is 1. Plus multiply by this K into this matrix, into this bracket. So it will become K A21 minus K A11 minus 2K A11 will be equal to 0. Now we have K A11 and minus 2K A11 will combine. So minus 1 minus 2, it will become minus 3K A11 will be equal to 0, and this will be equation number 1. Now we got the relation between A21 and A11. Now we'll solve for mass 2. So consider mass 2. Now we'll solve for mass 2. So for this mass, so downward force we are going to consider. So F2 positive, so F2, then plus K in bracket A31 minus A21, then upward is negative minus K A21 minus A11 will be equal to 0. See, here we have three forces, F2, then this K and this upward K. Okay, so I have written. Now multiply by K into this matrix, into this bracket. So it will become F2 plus K A31 minus K A21 minus K A21 minus this will become plus K A11 will be equal to 0. Now combine the terms. Here we have A21, here we have K A21. So combine that term. So F2 is 0 plus K A31 minus 2K A21 plus K A11 will be equal to 0. Okay. Now here all the terms are different, so we cannot combine. So I will mention at equation number 2. Now write from mass 3. So we have finished for mass 1, mass 2. Now we will write for mass 3. For mass 3, F3, then this upward, that is minus K A31 minus A21, and that will be equal to 0. Now what is the value of F3? It is 0. Minus K A31 minus plus K A21 will be equal to 0. Now transfer this minus side on other side, so it will become plus. Then this K will be cancelled with this K. So A21 will be equal to A31. I will mention this as equation number 3. Okay. Now here A21, A31 is same. So put this value in equation number 2. So put in 2. So K, here we just see A31, but A31 is equal to A21. So I'll write K A21 minus 2K A21, then plus K A11 plus K A11 will be equal to 0. Okay. Now we'll solve this one. So combine these two terms. So plus 1 minus 1, this will become minus K A21 plus K A11 will be equal to 0. Transfer this minus side here. So K A11 will be equal to K A21. K will be cancelled. So A11 will be equal to A21. So just see equation 3 and 4. A21, A31 and A11 all are equal. Okay. Now put this value in equation 1. So I'll write here, put in equation 1. So just put. So what is this equation 1? See here at the top we have equation 1. It is 1 plus K. What is the value of A21? A21 is nothing but A11. Here just see from equation 4. So K A11 minus 3K A11 will be equal to 0. So combine these two. So 1 plus, yes, you can write 1 plus minus 2K A11 will be equal to 0. Transfer this minus sign in other side. So 1 will be equal to 2K A11 but we want the value of A11. So transfer 2k on other side. So A11 will be equal to 1 divided by 2k. But from equation 3 and 4, A11 is equal to A21 is equal to A31, and the value of A11 is 1 by 2k. So we got all the values from the column 1 from that matrix. Okay. So by considering F1 is equal to 1, F2 0, F3 0, we got the first column. Now we'll have to consider here, instead of F1 we'll put it as 0 and we'll consider F2 is equal to 1. So I'll repeat the same procedure. Okay. So second, consider F1 is equal to 0, F2 is equal to 1 and F3 is equal to 0. Now by considering this one, again I'll draw this FBD. We have 3 masses, 2m, 2m and m. So again I'm going to draw this FBD. Okay, so just wait. I'll copy this one and we'll make the small changes in this FBD. Okay, so we'll paste here. Okay, so we have copied and pasted the same thing, but we'll have to change some of the things and that will replace. Okay, now this is the FBD. Now here what we have considered, here we have considered F2 is equal to 1. Okay, so that thing I'm going to implement, and here the A11, A21, A31 will be changed. That I will show. Okay. So for the reference I have taken. Now I'll make the changes. So this is the mass 2m. Now here the force 1 is 0. We have considered force 2 is 1, force 3 is 0. Now the upward force, what is the upward force? 2k into x1. So here we have to put the value of x1. So what will be the value of x1? See here we are going to determine displacement at 1, but we have considered unit load at 2. Here at 2, mass 2, so A12. Similarly this will become A22, this will become A32, means displacement at 3 due to load at 2. And if you compare with this one, then just see this matrix here. This is A12, A22, A32, A12, A12, A22, A32. Okay, so this will become 2k into x1, that is A12. Here x2 minus x1, so A22 minus A21, sorry, A12. And here x3 minus x2, so A32 minus A22. Okay, now we have FBD which is very much similar to the first FBD, just I have changed the displacement and force values. Now here we'll have to use Maxwell's reciprocal theorem. What is this theorem? The value of A12 will be equal to value of A21. Okay, and we have already calculated this value A21. Just see, it is 1 by 2k. So the value of A12 will be equal to 1 by 2k. So there is no need to solve in second case the mass 1. Okay, so I am not going to solve for mass 1 because we got the value of A12 by using the Maxwell's reciprocal theorem. Now we will find for mass 2 and for mass 3. So consider equilibrium. So for equilibrium condition, for mass 2, write F2 which is downward, F2, then this force downward plus K, A32 minus A22, then this upward force plus K, A22 minus A12 will be equal to 0. Now multiply. What is the value of F2? It is 1. So Ka32 minus Ka22 plus, multiply here also, Ka22 minus Ka12 will be equal to 0. Now whatever the terms common, solve for these terms. So just see, these two terms are common. So I am going to solve for these two terms. So here these two terms will be cancelled because this is minus K A22 and here will be having plus K A22. Just see here from equation, this term is plus, this term is minus. Sorry, I have made one mistake here. This is minus. So I'll change accordingly. Just wait. I have made a small mistake there. I'll rewrite this one. Okay. So multiply Ka32 minus Ka22. Then here again it is minus Ka22 and minus will become plus Ka12. Now, so 1 Ka32, this minus will become minus 2 Ka22. Then the last term is Ka12. And I'll mention this as equation number. Just see the last equation number, it is 4. So I'll mention this as 5. So this is the equation number 5. Now I have written this for mass 2. Now write for mass 3. So from mass 3, F3 is downward. Then the upward term, it is minus K A32 minus A22 will be equal to 0. Now multiply by K into the bracket. So Ka32, this will become plus Ka22 will be equal to 0. What is the value of F3? F3 is nothing but 0. So I will put 0 here. Okay. So Ka22 will be equal to Ka32. Kk will be cancelled. So A22 will be equal to A32. Now I am going to put this value in equation 5. So put in 5. Put in equation 5. So what will be the equation? 1 plus Ka32. A32 is nothing but A22. So Ka22 minus 2Ka22, and here we have A12. And what is the value of A12? By Maxwell's reciprocal theorem, it is 1 by 2K. So the next term is plus K A12, and A12 is 1 by 2K equal to 0. So the K will be cancelled. So solving this equation, 1 plus 1 by 2, so it will become 3 by 2 plus, see, this is plus term, this is the minus, so here it will become minus Ka22 will be equal to 0. So transfer this term in other side. So Ka22 positive, so transfer this K here. So A22 will be 3 by 2K. So we got the second term. See, the first term that we got by using the Maxwell's reciprocal theorem, that is A12. Now we got the second term, that is A22, and from this above equation, I will mention this as 6. From this equation, A22 is A32, but A22 is equal to A32, and what is the value of A22? It is 3 by 2K. So we have solved for next 3. So just go back. So we have these 3. Now we have to solve for the last one. Now for that again we have to consider, initially we have considered F1 is equal to 1. For second case we have considered F2 is equal to 1. Now we will have to consider F3 is equal to 1. So third one, consider F1 is equal to 0, F2 is equal to 0, and F3 is equal to 1. Now Again we'll have to draw FBD. See, for reference I'll copy this FBD. Okay, I'm going to copy this FBD for the reference and we'll make the changes. So whatever the changes that we want, I'll just make the changes. So here the force value and A value will be changed. So force value will be changed, then the A value will be changed. So I'm going to change the force value and A value. Okay, here also in bracket is going to change. Okay, so we'll make the changes accordingly. So we have the reference of this FBD. So initially I'll put the value of forces. So what will be the forces? F1 is equal to 0, F2 is equal to 0, and here we have considered F3 is equal to 1. Now what will be the value of x1? X1, here we are calculating the displacement at 1, but we have considered force at 3. So it will be A13. Similarly here we can write A23, here we can write A33. What is meant by A23? Displacement at 2 due to load at 3. Here displacement at 3 due to load at 3. Now accordingly we will put. So the spring force will be 2K into displacement x1. So x1 is A13. So displacement is A13. Here it is K into x2 minus x1. x2 is A23 minus x1 is A13. Now here stiffness into x3 minus x2. So A33 minus A23. Okay, so we have finished with our FBD. Now use Maxwell's reciprocal theorem first. So from this Maxwell's reciprocal theorem we will get the two values. Just see, we are going to calculate for this last column. The value of A13 will be equal to A31. We have already calculated A31. Then value of A23 will be equal to A32. We have calculated already these two values which are equal to this one. Okay, so I am going to directly write the value of A13 and A23. So the value of A13 and A23 we have already calculated, which will be equal to A31 and A32. Now just tell me the values. Okay, just see what is the A32. This A32 is nothing but 3 by 2K. So this one is known. Now A13 we have calculated in the first condition. So A31 is 1 by 2K. A31 is 1 by 2K. So I will write here 1 by 2K. Means we already calculated the two values by Maxwell's reciprocal theorem, and just we have to determine only one, that is A33. So this problem will become smaller as we move further. Now we have to calculate A33, means consider equilibrium condition, but for that there is no need to solve for mass 1 and mass 2. Directly go to mass 3, because A33 in mass 3. Now right, so F3 is downward. So F3, I have taken this as positive. Then the upward force is negative, minus K A33 minus A23, and that will be equal to 0. So what is the value of F3 is 1 minus K A33 minus plus K A23, and that will be equal to 0. Now just put the value that we know. So K A33 we don't know, but we have the value of A23, and the value of A23 is 3 by 2K. So this will become 3 by 2K equal to 0. So this K will be cancelled with this K, and 1 plus 3 by 2. So this will become 5 by 2 minus K A33 will be equal to 0. Now transfer this negative value on other side. So 5 by 2 will be equal to K A33. Now transfer this K here. So A33 will be 5 by 2K. So we have calculated for all the values. Now just write the final answer. So the final answer means the influence matrix. That matrix is A11, A12, A13, similarly 21, 22, 23, then 31, 32, 33. Whatever the values that we do know, we'll put. So go to the first case and see all are same. A11, A21, A31, it is 1 by 2k. So it is 1 by 2k for first column. Then 1, 2, 2, 2, 3, 2. 1, 2, 2, 2, 3, 2. Just check the value of 1, 2 is 1 by 2k and 3 by 2k. 1 by 2k and 3 by 2k. So here I'll write 1 by 2k and then it is 3 by 2k, 3 by 2k. Then for A33 it is 5 by 2k, and for this one, this value will be same, so 1 by 2k, and for this one, this value will be same, 3 by 2k. If you want to check, just go above and check. So value of Maxwell is 1, 3, 2. I have made one mistake here, it is 1 by 2k. Okay, so 1 by 2k for first and then 3 by 2k for second. So 1 by 2k, 3 by 2k, 5 by 2k. And this is the answer. Okay, thank you.